Ladies and gentlemen, we have our chief guest of today's program with us, Shri Dipen Singh sir, Chairman and Managing Director, IREL Limited, along with other respected dignitaries of IREL, Mr. V. Chandrasekhar, Dr. B. S. Salwar, Mr. Mahavir Veena, and other dignitaries. As we all know that it's a very novel cause that we all are here to celebrate a very special occasion of the festival, which we say Science and Technology, that is the National Technology Day. Although it was yesterday on 11th of November, but due to certain unavoidable reason, today we are here gathered to celebrate this special occasion. Not only for National Technology Day, we are celebrating here and gathering, but along with that, another auspicious and a very unique special occasion is that we will be having a curtain raiser program of our 1 week, 1 lab program that will be having from 14th of May to 18th of May. So it itself become a very unique occasion that we all will be celebrating and eye witnessing these two events all together from today. And rather, I would say that from today itself, we'll be celebrating the program and many other things till the end of 18th of the May. That is 1 week, 1 lab program. With this, I would request our respected chief guest of today's program, Mr. Dipen Singh sir, Dr. Amish Kumar Srivastava, Director sir, Dr. Engineer Manish Mudgal sir, Dr. Mohammad Akram Khan sir, to kindly come up on the stage. For this, I will request to kindly escort sir, please. Thank you, sir. We are really honored to have you with us in this very special occasion. And we are highly thankful to you for giving your precious, valuable time to celebrate and to present in this particular campus at CSIR-AMPRI Bhopal. Respected chief guest of today's program, Dr. Dipen Singh sir, Chairman and Managing Director, Indian Rare Earth Limited. Respected Director sir, Dr. Avnish Kumar Srivastava, CSIR-AMPRI Bhopal Director, as well as CSIR NML Director. Ladies and gentlemen, respected dignitaries, distinguished guests, and all the dignitaries which has been came from our EL officials, ladies and gentlemen, technical administrative staff, I, Dr. Sarika Verma, Principal Scientist, welcomes all of you once again in this very special occasion that we all are gathered here in the celebration of National Technology Day. And along with this, we are here to have our very special curtain raising program of 1 week, 1 lab. As all of you know that the Indian government has officially declared 11th May as National Technology Day in India to commemorate the first of the 5 nuclear bomb tests which were carried out on 11th May 1998 by the Indian Army at the Pokhran test range under the name of Operation Shakti. Basically, National Technology Day is an annual event which is observed in India to commemorate the India's technologies achievement. The day basically is dedicated for promoting the science and technology in the development of nation, particularly among the students, young people, and other societal personalities. This day glorifies the importance of science and technology in daily life and motivates students to adopt science as a career option, as all of us knows that. With this word of hope, igniting our minds to fulfill this purpose of the very special day that we are here and directing all of us into a new era of advanced technical and scientific innovation leading to the betterment of humanity. Let us celebrate this day. Let us enjoyable have the fun in this day and to be a proud to have this particular day. Not only the National Technology Day that we are celebrating, but curtain raiser event as well as of 1 week, 1 lab. With this, now I'd like to request our respected director, sir, to kindly have a floral welcome to the chief guest of today's program, Dipendra Singh sir, Chairman and Managing IREL Private Limited. Thank you so much, sir. With this, I would request Dr. Mohammad Akram Khan sir kindly welcome another dignitaries which has been here with us, Mr. V. Chandrasekhar sir. Kindly welcome them also. We are really honored for you sparing the time, all of you, sir, and there in our campus. Thank you so much. With this, I would request Dr. Engineer Manish Muttal, sir, to kindly welcome Dr. B.S. Talwar, sir. I would request Dr. Satanand Mishra to kindly welcome Mr. Mahavir Meena, sir. Thank you so much for all your kind presence and eye witnessing the things. Ladies and gentlemen, as all of you know that we are having our guests right from the morning. They have eyewitnessed certain technologies and the work themselves that has been happening in MP Bhopal. And after that, they all are here. I'm sure that sir, you would have seen what people are doing. Not only the concept is there, lab to land to lab. That's what we are. Thank you so much for that. Now, ladies and gentlemen, with this to start the program with, I would like to invite our director, CSIR-AMPRI Bhopal, Professor Dr. Avnish Kumar Srivastava sir, for his welcome address and opening remark. But before that, I would like to share the list of achievements. And actually, it is very, very difficult to put them into the words, but it's there to share with you. As all of us know that Dr. Avnish Kumar Srivastava is the director of CSIR-MP Bhopal, director of NML Jamshedpur, as well as he is the theme director of 4M theme CSIR projects. Dr. Srivastava has earned his master's in physics from IIT Roorkee and master's in technology in material sciences from IIT Kanpur. He holds a PhD degree in meteorology from IISc Bangalore. He is known for his knowledge and expertise in the field of materials, processing and characterization, semiconductor science, nanostructural material, composite, and many, many more things. He has more than 375 publications in very high impact journal with more than 5,000 citations with his work also highlighted in Science. It's our privilege to mention that Professor Srivastava is among the top 2% of most cited scientists which has been awarded by Stanford University. Along with a deep knowledge of fundamental science, he has a command of technology development. He has more than 15 patents and almost the identical number of know-how transfers in his credit. He has been the editor of many books, which is applicable in versatile and the various areas. He is currently serving as a chief editor for the Applied Innovative Research Journal. He has been instrumental in establishing various research facilities at CSIR, NPL, as well as in CSIR and among various facilities, the most important facility that has been established by our respected director, sir, which is very few among across the country, is the TAM. Along with that, Raman Spectra with two version has been in the Raman CTR 300 and CTR 150 Raman spectrometer. It has helped and strengthened the knowledge generation capacity of the institution in R&D working globally. For the last few years, under the guidance and leadership of Professor Srivastava, of CSIR-AMPRI Bhopal is working as a principal institute and successfully hosting the event of traditional craft and artisan meet at India International Science Festival in all the forum. He has been a fellow of number of organizations like IIM, MRSI, Mineral Metals, and many more. He has several awards in his name. Few of them are Meteorologist of the Year Award by Ministry of Steel, MRSI Medal, INSA COSEP Fellowship, NRDC Award, and many, many more. The list is really long. Professor Srivastava also served as various committees of the Ministry of Science and Technology, DST, TIPEC, etc. He has also worked as national coordinator in Bureau of Indian Standard and contributed immensely to this field. He has worldwide collaboration where he is closely associated with various institutes. Some of them are Argonne and Brooklyn National Laboratory Technical University, Darmstadt, Germany, Department of Energy, Italy, and so on. The list is very, very long, and it is really full up of all the uncountable prominent titles in the world. Now, not taking much of the time, I would like to request our respected directors kindly have the welcome address and thank you.
Good afternoon. Namaskar to all of you. We are very fortunate to have today with us Sri Dipen Singh, Chairman and Managing Director of Rare Earth Limited. And we are also fortunate to have his colleagues with us in this today's National Technology Program. The National Technology Program is in fact a very, very auspicious day for the scientific and technological community. In the sense that 5 successful nuclear tests have happened in Pokhran, Rajasthan on 11th May 1998. On the same day, ANSA 3 aircraft was tested successfully by CSIR National Aerospace Laboratory, Bangalore, and Trishul surface-to-air missile was tested. So, keeping in view that such successful technological innovations in the country, the then Prime Minister Sri Atal Bihari Vajpayee ji declared 11th May as National Technology Day. And since 1999, this day has been celebrated every year to remember our initial discoveries, technologies, and also to remind us to develop more and more such path-breaking technologies, have lesser and lesser dependence on foreign technologies and developments. This year, the National Technology Day becomes more important because we are in the year of Azadi Ka Amrit Mahotsav. We are also celebrating the presidency of G20, and for CSIR fraternity, it's more important, or at least equally important, that after the 80 years of CSIR, every lab of CSIR is going through 1 week, one lab, showcasing of their science and technology, what they have done. So whole year is divided in different duration for every lab so that they can showcase their science and technology, what they have done. They can interact with industries, academia, entrepreneurs, R&D lab people, society, school students, young engineers, researchers, and a common man. So this year has become in that way very, very important, and CSIR is playing a very crucial role. Moreover, when our chief guest, he is awardee of Atmanirbhar Bharat 2023. I was going through his CV, and then this is the most attractive point I found, that he is the awardee of, I think we all should clap for that, the awardee of Atmanirbhar Bharat 2023, when India really wants to become self-reliant, having 5 pillars: economy, infrastructure, demography, demand, and system. So, as a scientific community, as a technical community, it's our responsibility to strengthen all 5 pillars of Atmanirbhar Bharat. We are also responsible to fulfill or contribute towards the sustainable development goals, which are being basically crafted by United Nations and adopted by almost all countries. Niti Aayog has adopted 14 out of 17. It starts with no poverty, zero hunger, good health, quality education, uh, gender equality, and so on. So we have to see and find out the ways how we can contribute in all these directions. Our international problems also starts with economic instability, health, climate change and all. And as a scientist, we know that in various ways we can contribute. So whenever we celebrate this National Technology Day, and especially when we are really in transition stage from developing to developed country, this is our responsibility as a scientist, as a technologist, and as any support system. It's our responsibility being part of a organization which is a research organization. It's our responsibility to see in what best way we can find out the way we can contribute in making our country Atmanirbhar, which maximum extent we felt during the COVID time. And that time only our Honorable Prime Minister and President CSIR Shri Narendra Modi ji coined this self-reliant India, this terminology, and where we all are intend to continue. So with this, I wish you for this success of this today's National Technology Day. This day is more important this year for us because we are going to have the curtain raiser of our 1 week, 1 lab program also, which will start formally from 14 to 18, and it will be inaugurated by none other than the Governor, Honorable Governor of Madhya Pradesh, Excellency Shri Gangubai Patel ji. And so he has kindly agreed to come to CSIR-AMPRI premises for the inauguration on 14th. And for celebrating that curtain raiser, we are going to have today by our chief guest, Shri Dipens. Thank you very much. Jai Hind. Dhanyavad.
Thank you, sir. Thank you for your kind words. Now to move ahead, ladies and gentlemen, so that we are here to celebrate this Nation Technology Day and the Curtain Raiser program. For this, I would like to invite Dr. Engineer Manish Muggal sir to have the kind words with the August gathering regarding the Nation Technology Day and the event that we are celebrating, curtain raiser of 1 week, 1 week.
Afternoon. Respected chief guest of our today's function, Sri Dipen Singh sir, and Managing Director, respected Director, CSIR-AMPRI, Professor Avnish Kumar Srivastava sir, colleague Khan, Sarika Verma, senior colleagues, scientists, staff, administrative staff, students and fellows of this particular institute, ladies and gentlemen. This sir has already told you about the National Technology Day. I'll just of that. So we are here today to celebrate this National Technology Day, which is celebrated on 11th May every year in India to commemorate in India's technical achievements and to encourage the pursuit of scientific and technological excellence in the country. The day marks the anniversary of India's successful nuclear test in 1998, which established India as a nuclear power and demonstrated the country's advanced technologies capabilities. National Technology Day serves as a reminder of importance of science and technology in the development of the nation and welfare of its people. It is a day to celebrate contribution of scientific community, engineers and innovators who have made significant contribution to India's growth and development. The day is also an opportunity to promote and encourage the pursuit of technological innovations and inspire young peoples, young students to pursue career in science and technology, engineering. National Technology Day is celebrated with events and activities, seminars, exhibitions, technological fairs to showcase India's technologies prowess and to encourage collaboration and knowledge sharing among the scientists, researchers, and technological professionals. So, with these words, I once again welcome all colleagues, and I am thankful to Dr. Singh sir for accepting our invitation to be chief guest of this particular function. Uh, Thankful to Director sir for mentoring this particular. Thank you so much. Jai Hind.
Thank you, sir, that you have shared with our gathering. Now, ladies and gentlemen, now we'll move ahead with another important part of the program. That is the release about 1 week, 1 lab program. For the same, I would volunteers to brochures have this brochures. And for the curtain raiser also, I would with this now to move ahead, I would like to invite Dr. Mohammad Akram Khan sir, Chief Scientist and Coordinator of 1 week, 1 lab program to kindly highlight about the program and share the things about the 1 week, 1 lab program that we have thought and discussed about that. Thank you, sir.
Honorable Chief Guest of today's National Technology Day function, Shri Deependra Singh Sir, Chairman and Managing Director, Indian Rare Earth Limited. Respected Dr. Avnish Kumar Srivastav Sir, Director, CSIR-AMPRI, and also Director, CSIR-NML, Additional Charge. My colleague, Dr. Manish Mudgal, Chief Scientist and Coordinator of this National Technology Day event today. Dr. Sarika Verma, all my senior scientists seated in the audience, my senior colleagues, ladies and gentlemen. it is indeed a matter of great privilege for me to say few words about the 1 week, 1 lab event that we are going to start very soon at CSIR-AMPRI. As a coordinator, I feel very privileged that I have been assigned this responsibility to say something about this event. Ladies and gentlemen, we just had the curtain raiser of this 1 week, 1 lab by our honorable chief guest, Shri Dipen Singh sir. And now you must be knowing that we start with this event from 14th of May. So on 14th of May, we are going to have a formal inauguration by His Excellency, the Governor of Madhya Pradesh, Shri Mangu Bhai Patel ji, who has kindly consented to be the chief guest for the inaugural function. And that would take place at this very auditorium from 11 a.m. onwards on 14th of May. During the inaugural function, we also have planned the inauguration of the Expo, which is aimed at showcasing important technologies and products of CSIR-AMPRI, broadly in two segments. One is the one which have already been transferred and commercialized. And the second segment would be about the technologies which are ready for transfer and which are at a high TRL where we can attract the industries. This activity is being looked after by my senior, Dr. P. Ashokan sir and his team. So when we start this event on 14th, we have the inaugural and subsequently we'll have a number of events. Now, just to give you a background of what is this 1 week, 1 lab. As has already been told by respected director sir, on 17th of December 2022, our Honorable Union Minister for Science and Technology, Dr. Jiten Singh ji, announced that all 37 CSIR laboratories all across the country would be celebrating this concept of 1 week, 1 lab in a cyclic manner. Now, what is meant by this is that a common man needs to be made aware about the great work that is being done by CSIR labs, both in terms of science and technology and also in terms of the societal benefits that we are doing. So with that broad objective, this program has been launched by our Honorable Union Minister, Dr. Jiten Singh ji. And as far as I remember, CSIR-AMPRI is going to be the 19th lab in the sequence of this 1 week, 1 lab, which will be now hosting this event from 14th to 18th of May. Now, all of us very well know, but for the kind benefit of our honorable chief guest today, sir, we are working in large number of R&D areas, and some of them include graphene, 2D materials, waste to wealth, nanomaterials, drinking water, societal mission, additive manufacturing, 3D printing, lightweight metal, metallic foam, wood substitute, and so on and so forth. So with that kind of an expertise that CSIR-AMPRI has, this entire program of 1 week, 1 lab under the leadership of Director Sir has been designed. And on each day, from day 1 to day 5, 14, 15, 16, 17th, 18th, each day we have 2 events per day. So on 14th, we are going to have the inaugural function. And in the second half, we have a thematic discussion on advanced and futuristic materials. Then on 16th, we have a complete day dedicated in 2 sessions on industry, meet, and interaction. Because, sir, there is a great need which CSIR realizes that we need to have an industry connect. And CSIR is already associated with large number of industries. A lot of projects are being sponsored by them as well. But to communicate to the industry in a broader way the strength that we have, and also to the common man, this program has been designed to create an outreach, to make them aware that what is the whole purpose of having CSIR community, CSIR labs, the grand, expertise, infrastructure that we have, and in what way we are contributing to the benefit of a common man in a day-to-day manner. So, sir, on 15th of May, we have industry meet and way forward in the first half. And then in the second half, we have technology demonstration and dissemination. So this technology demonstration and dissemination has been put, sir, in the form of an expo. which would be inaugurated on 14th May by His Excellency, the Governor of Madhya Pradesh, where we are going to showcase all our important technologies, processes, and products. On day 3, that is on 16th of May, we start with R&D and academia meet. And this is intended with a purpose to gel different academia institutes with R&D. We are already interacting with large number of academia institutes like various IITs, ISER, AIMS. But through this program, sir, we want to look forward what new can be done, what new is more attainable, with a broad objective of, again, creating an outreach and creating benefit to the society. Then on day 3, that is on 16th May, in the second half, we have Young Researchers Conclave. And the target audience, sir, of Young Researchers Conclave is all the youngsters, mainly the youngsters, the future researchers and, scientists and academicians of this country. We also have a strong ACSIR base, sir. A lot of students are pursuing their integrated dual degree programs of MTech and PhD, and also PhD programs in different disciplines at CSIR-AMPRI. So not only those young researchers, but beyond that also, we are inviting a poster session, some dedicated talks, and each session will have some invited lectures and talks as well. So on 16th, in second half, we have the Young Researchers Conclave. Then on 17th, first half, sir, we have the Jigyasa and the awareness program. It's largely about attracting various students of different schools and colleges, and primarily students in this case, sir. CSIR-AMPRI is already having a very good network with large number of KVs and Navodaya Vidyalayas. And we have been interacting with them. We have been inviting those school students and teachers and giving them popular science lectures. But through this program of 1 week, 1 lab, we are going to, again, highlight and generate their interest towards science as a career. So that is the whole purpose of having this session, 17th May first half, which is Jigyasa and awareness program. And the second half is dedicated to an open day, which is for the common public, which will include anyone and everyone from the city and beyond city limits also, who would like to visit CSIR-AMPRI and see the kind of infrastructure, the kind of facilities, the expo that we have showcased. They can have a free interaction with scientists, and a popular lectures has also been planned. Then, sir, on 18th, which is the last day of this 1 week, 1 lab, we start with the skill development and tribal welfare. CSIR-AMPRI is committed to and is already working in a big way for skill development. We have a lot of programs under which a lot of students come to us for their MSc, MTech dissertations and trainings. So that is already being done under skill development. A lot of engineering college students do visit this institute and do their training and dissertations. And sir, we have a strong presence as far as the tribal welfare activities are concerned. So that we have already done in the valley of Patalkot. We are also doing it in Jhabua district. We have come up with the concept of makeshift hospital. So many things are there that we are going to cover under series of lectures, panel discussions, plenary talks. And a whole program has been, sir, scientifically designed. In lot of efforts have been put under the leadership of Director, sir. And then, sir, on 18th May, we would end up with the valedictory in the second half, where again, important dignitaries have been invited, where we'll sum up with the entire proceedings of the 5-day event, and we'll come up with the recommendations, how best things can be improved. So this is the whole outline of having the 1 week, 1 lab at CSIR-AMPRI. And sir, I'm very happy to share with you that lot of top leaders of CSIR family have already confirmed their participation for this event. We are going to have director from CSIR NPL, CSIR NISPER, CSIR NIST Trivandrum, and a lot of former director from NBRI, Professor Saroj Barik. IIT professors have consented to come. Director of ISER would be gracing the occasion in one of the events as the chief guest. So we have got a whole list of events that has been prepared for this particular aspect. And a lot of effort, sir, has gone by the entire committee and the team that has been constituted on this. So I take this opportunity to also thank each and every committee members. We had constituted a lot of committees, sir, on this. We had committees for specific activities. We had committees for specific tasks. So I take this opportunity to thank all the activity coordinators, conveners, respective members, and also the subcommittees who are taking care of entire logistics, travel, transport, accommodation, printing. So I am extremely thankful to each and every one of you for this support on this. And lastly, I take this opportunity to invite each and every one of you on behalf of respected Director Sir, Director CSIR-AMPRI. I invite each and every one of you. I invite press and media. I invite common people. I invite who is a witness to this curtain raiser to please come and attend this 1 week, 1 lab event at CSIR-AMPRI Bhopal. Thank you so much, sir.
Thank you so much, sir. You have beautifully explained about how we are going to celebrate our 1 week, 1 lab program. You have shared us that under a single umbrella in the premises of CSIR-AMPRI Bhopal, how with the guidance, support and motivation of our respected director, sir, we have designed our this 1 week, 1 lab program from 14th to 18th of May. It will be started with the inauguration and ended with the valedictory. But in between, you have, sir, rightly shared with all of us that how we have covered the entire gamut of the people, right from the industry to the academia, to the student of college or the school or the societal people, tribal, and each and everything. So we, during the finalization of this program, have made it sure that whatever work we people are doing at CSIR-AMPRI Bhopal should reach to the society in each and every way, whether it is a knowledge generation, knowledge dissemination, knowledge demonstration, and all those things. I am very sure that whatever efforts that we all people have done for this 1 week, 1 lab program will definitely reach to the masses. And yes, we are really happy and honored that, sir, we will be having many different dignitaries of higher official. They will be eyewitnessing our 1 week, 1 lab program at different events. So thank you so much, sir, for your wonderful briefing of our program. Now, ladies and gentlemen, to move ahead, another very important event of this program is the CSIR-AMPRI film that we have made. Sir, this film basically shows how and what work we are doing at AMPRI Bhopal. And not only this, the lab concept, we are working on the land concept at all, and also how the society is directly getting the benefit. For this, I would like to invite Dr. Engineer Manish Mudgal, sir, Chief Scientist and Coordinator of this National Technology Day program. Kindly have this film, CSIR-AMPRI capsule film.
So respected chief guest of the function and respected director, sir, with your kind permission, can we release this film now? So it's a capsule film of AMPRI.
CSIR-AMPRI. CSIR-AMPRI, innovating excellence. In order to match pace with the advanced economies, it is very important for any nation to become science and technology sufficient. New innovations and technologies are allowing scientists to manipulate substances at an atomic level and create new purpose-built materials that massively outperform naturally occurring materials. Advanced Materials and Processes Research Institute, AMPRI, a constituent laboratory of the Council of Scientific and Industrial Research, CSIR, is located in Bhopal, Madhya Pradesh. Under the dynamic leadership of President CSIR, Vice President CSIR, Director General CSIR, and its Director, AMPRI is serving the crucial needs of Indian industries, society, and the strategic sector in the areas of engineering materials, components, and process development.
Our vision is to see CSIR-AMPRI Bhopal as one of the world's leading institutes in research in the area of advanced novel materials made through conventional and advanced processing techniques, with its proven expertise and facilities ultimately contributing to the CSIR mandate to fulfill nation's need and expectations.
AMPRI Bhopal was established on 14th of May 1981 as Regional Research Laboratory RRL. It started functioning from CSIR, the parent organization in New Delhi. Subsequently, it was relocated to Bhopal in 1983. Based on the core strength and R&D expertise, RRL was renamed as Advanced Materials and Processes Research Institute, AMPRI, in March 2007. Using new technologies and innovations, the scientists at CSIR-AMPRI are working relentlessly and opening new doors of opportunities. The current activities of AMPRI are broadly categorized under lightweight materials, nanostructured materials, smart and functional materials, waste to wealth, radiation shielding materials, cement-free geopolymeric concrete, bamboo composite, parali composite and wood substitute, graphene-based 2D materials. AMPRI is engaged in R&D on materials and processing with a special focus on the synthesis, characterization and processing of different advanced materials. Lightweight materials. CSIR-AMPRI has developed open cell carbon and aluminium foams for energy storage, fast charging, high energy density, aluminium ion batteries. Use open cell aluminium foam as a cathode and graphene-coated carbon foam as an anode. CSIR-AMPRI has also developed pouch cells using these open cell foams. CSIR-AMPRI has developed closed cell aluminium foams for blast mitigation and impact energy attenuation at a scale of 30 kg per heat, 150 kg per day. These foams are used as core material for making blast resistance panel or anti-mine boots. These foams have been tested for crash energy absorption. Waste to wealth. Lead-free X-ray shielding tiles developed by CSIR-AMPRI using iron-rich red mud. The tiles have a unique joint-free interlocking system that prevents radiation leakage and are long-lasting and have high temperature stability. The upscaling is being done in collaboration with Prism Johnson Limited and is available in market. Recently, the Center for Advanced Radiation Shielding and Geopolymeric Materials was established at AMPRI Bhopal. Upscaled process for making non-toxic heavy-density radiation shielding synthetic aggregate have been developed by CSIR-AMPRI, utilizing red mud as an alternative of hematite ore. Using synthetic aggregate heavy-density gamma-ray shielding concrete have been developed. Gamma-ray shielding concrete can be used for construction of nuclear installations and medical diagnostic centers and bunkers for strategic sector. AMPRI has developed fly ash-based cement-free advanced geopolymeric concrete. It is an eco-friendly, water-curing free concrete useful for construction of rigid pavements roads and was demonstrated at AIIMS Bhopal. AMPRI has developed environment-friendly advanced pavers block from copper tailings as a total replacement of river sand. It has also developed advanced geopolymeric tetrapods using silofly ash, sea sand and sea water. CSIR-AMPRI has developed corrosion-protective geopolymer coating for mild steel by utilizing fly ash. Using agro-waste parali and industrial waste particulates and fibers. CSIR-AMPRI has developed a technology for making evergreen hybrid particle board and composite wood. The hybrid composite panels manufactured using parali are ready for commercialization. Smart and functional material. CSIR-AMPRI is working on shape memory alloy with AI-enabled technologies for actuators development. The applications of these actuators are for automobiles, robotics, prosthetics, micro-positioning and other industrial applications. The institute is also working on development of instruments for the characterization of homeopathic medicines to detect ultra-low metallic concentration. It is also working on electromagnetic joining process for similar and dissimilar metals. AMPRI is also working on latent heat energy storage tanks for the storage of solar energy or waste heat. AMPRI has developed an innovative piezoelectric nano generator using a two-dimensional nano layer and smart nano composite. It has also developed graphene quantum dots based on self-powered nanosensors and wearable device. CSIR-AMPRI has set up India's first electrochemical 3D printer to fabricate metal nanoparticles. In this, nanoparticle of noble metals are deposited and are used as the LSPR substrates for the investigation of various pharmaceutical drugs. CSIR-AMPRI is also fabricating supercapacitor electrodes of carbon quantum dot through the 3D printing process. AMPRI is working on 3D concrete printing technology which can be used for constructing buildings in short duration, minimizing labor costs and material wastage. Characterization. Characterization is an integral part of R&D work related to materials. CSIR-AMPRI has established state-of-art facilities for material characterization and process optimization. CSIR-AMPRI and Messrs Technos Instruments have initiated project to develop India's first indigenous IndiRAM CSIR Technos Raman CTR series spectrometer. The institute is equipped with a field emission-based transmission electron microscope along with TEM sample preparation facilities. With the help of this equipment, scientists can characterize the material at the nanostructure level. Societal. CSIR-AMPRI Bhopal and CSIR-CBRI Roorkee have jointly licensed the technology of makeshift hospital. The fabrication of the structure makes use of prefabricated steel portals which are foldable, easily erectable, reusable, safe and comfortable. This technology has been implemented at many places. CSIR-AMPRI has developed a water filter based on nano-absorbent technology for the removal of fluoride, arsenic and microorganism from the water. These filters are cost-effective, does not require electricity and does not waste water. These filters have been installed in various affected areas. AMPRI has also developed advanced sensor for water quality monitoring using IoT and AI. CSIR-AMPRI have developed nanofibrous herbal dressings for wound care using an electro-spinning technique. Antimicrobial biodegradable food packaging, antimicrobial PPE, antimicrobial coatings for wood panel, medical implants and fixtures and accessories in hospital settings. CSIR-AMPRI have developed metallic foam for the bone scaffold. It has also developed magnesium alloy for biodegradable orthopedic implants. CSIR-AMPRI Bhopal has developed advanced bamboo composite. It has better dimensional stability, density, mechanical strength, and is fire and moisture resistant. A demonstration bamboo batak, an eco-friendly hexagonal sitting place, has been constructed using bamboo composites. AMPRI has developed sisal fiber-based technology for sustainable rural employment, income generation, and women empowerment. To cater to the future needs of scientific activities, a 5-star rated green building of the laboratory with an area of about 13,000 square meter is under construction in the main premises.
CSIR-AMPRI is significantly contributing towards strengthening the idea of self-reliant Atmanirbhar Bharat, a campaign started by our Honorable Prime Minister and President CSIR, Shri Narendra Modi ji.
Tirelessly engaged in advanced research and development activities in frontier and multidisciplinary research areas, the dedicated team of scientific, technical and administrative staff strives for achieving excellence and contribute to the needs of the industry, social sector and the nation at large. Team CSIR-AMPRI is marching ahead, keeping pace with the future R&D challenges.
Ladies and gentlemen, in a quick glimpse, sir, we have seen that what and how CSIR-AMPRI is working on, what is the strength of CSIR-AMPRI and how we are progressing and in what all areas we are working. So to move ahead with ladies and gentlemen, now not taking much of the time, we are really waiting to listen from our chief guest of today's program. It's a proud privilege that we have an eminent personality with us, Shri Dipendra Singh sir, Chairman and Managing Director, a chief guest of today's program. Our respected chief guest hardly needs any introduction, but as in customary, I will share his brief biodata with you before he will share his speech and talk with you. Mr. Dipendra Singh is a chairman and managing director of IREL India Limited, a central public sector undertaking under the aegis of Department of Atomic Energy, Government of India. Mr. Singh is having rich and varied experience spanning over 3.5 decades in strategic corporate planning, project management, production planning and control and quality management systems, human resource management, skill development, and industrial training. Prior to his present assignment, he has worked as a director marketing at IREL, director cooperative planning and business development at EDCIL Limited, that is the Educational Consultant India Limited. Mr. Singh is a graduate in engineering, MTech in industrial design, and MBA in marketing. He has a credential of association in various projects under the World Bank, OPEC, that is the Organization of Petroleum Exporting Countries, and Asian Development Bank, including various significant projects of Central Government of India. He is a recipient of UNITO Fellowship, that is the United Nations Industrial Development Organization in Germany. He is a recipient of various prestigious awards and accolades in his credit, as respected director sir was talking about in his speech. Now, few of them are Atmanirbharta Award, which was conferred by Indian Analytical Science Congress, IASC 2023. Outstanding Business Leadership Award during 15th International Business Conclave and Award, Best CMD Corporate Management Innovative Leadership Excellence Award, Leading Director Award 2021, which was conferred by Green Tech Foundation, CEO of the Year Award, which was conferred by National Feeder Award in April 2021, International Leadership Innovation Award, and many, many more. With credited for more than 65 presentation in national and international conferences, he is actively participating in various professional bodies and sharing his experiences and contributing for the welfare of society. Few of them are President of Rare Earth Association of India, Chairman of Western Region, President of Indian Institute of Metals, Mumbai chapter, chairman of processed mineral panels, member of managing committee, and many, many more things. The list of achievement of our respected chief guest of today's program is very long and it is really challenging for me to cover all this in a very short time. We are really honored to have you with us, sir, as a chief guest of the program. With this, it is a privilege to me to invite you for the today's program to address the August gathering, sir. Please. Thank you, sir.
Director CSIR AMPRI, Dr. Srivastav, Dr. Mudgal, Dr. Khan, Dr. Mrs. Sarika Verma, senior scientist in the audience, friends from CSIR AMPRI, ladies and gentlemen, and my colleagues from IREL. Indeed, it is a great pleasure for me to be amongst galaxy of scientists on the occasion of this technology day. And we, being a part of atomic energy, we really cherish this technology day year after year. And this year we are celebrating 25th year of completion of this starting of technology day. And I am proud to announce that yesterday, one of the important project under this Self-Reliance India was dedicated to nation by Honorable Prime Minister, which was executed by us as at Visakhapatnam, and that was the reason I could not be here, and this program was to be shifted. It, even more, it was really interesting, and I was really thrilled to see, witness various technologies developed by CSR-AMPRI. And Dr. Srivastava was kind enough to take me physically to those developments, those research initiatives, and even more I could see in the film. And I would like to compliment Dr. Srivastava and his team for doing this commendable work in the field of science and technology. I'm also happy to share with you during this technology day, because being a part of a technology driven company and attending a technology day with a leading CSIR laboratory, I'm indeed quite happy to be part of this program. When I was looking at your brochure, which was just released, I could find certain important mention there, like material for future, nanotechnology, clean energy, etc., etc. And Dr. Srivastava also mentioned in his speech that we are looking forward, we are embarking upon to address the challenges pertaining to climate change, clean energy, sustainability, etc., etc. So today I thought it will be a good opportunity. I will try to connect you with one of the material which is very relevant in today's scenario and which could be instrumental to address all these issues, and that is rare earths. And we deal with rare earths. Rare earth is a part of our product. So I thought I will introduce you that material and also call upon to think over and conceptualize certain projects based on this material so that we are mutually benefited by this. So starting with this, the rare earths material for shaping the future. How do you- Achha, okay. So these are the contents on which I'll be making the presentation. So you might be knowing that in the periodic table, at the bottom most, there are two series, lanthanide and actinide. So lanthanide series are called as rare earths, and they are separate from means Bell periodic table because they are quite inert. Other than oxygen, their reaction is also quite difficult. So other than these 15 elements, there is scandium and yttrium, which is also considered part of the rare earths. So this is the important part of rare earth, that as uh, energy or fuel or oil is essential to any industry, similarly, the rare earths are essential in case if we are aspiring to have a superior technology, niche technology, or something different than the normal one. So that is the reason the rare earths are the forte of developed country. And in the developing country or the underdeveloped country, even though it is found, there is not much of the development of these materials. But whereas in the developed countries, there is a lot of push and pull for this material. So these are the material which adds to the superior performance, and how it adds to that, that is technical superiority, miniaturization, and normally it is used in a very small quantity in various gadgets, various equipments, various material which we are using day to day in our life. And these are e-mobility like electric vehicles, green energy, wind energy, catalyst, which is used in each and every silencer of our automotives, consumer electronics, defense, aerospace, etc. And if we look at the from the viewpoint of importance to clean energy, versus the supply risk. So you will find that the topmost material, for five material you can find here, that is neodymium, dysprosium, europium, yttrium, and terbium. And these are all coming under the rare earths category. So they are quite critical because first thing, they are not found in a high concentration, and the situation or circumstances are such that the monopoly of a specific country, that is China, is there, and therefore the other people find it quite difficult to produce it economically in an economic viable manner. So we could do it because we have started much earlier than what China did, and our existence is there way back since 1950. So here, this fact can be seen that there are many places where these rare earths are found, but when we look at what are the countries where these rare earths from the ore are extracted and made available in a industry utilizable form, we can count in fingers. There are only 3 to 4 countries, and India is one among them. Now, this is the chart showing what are the different sources from where rare earths can be obtained. So primary ores, then these out of 17 elements, the lighter rare earths are available here, and they are used to make these many products like magnet, catalyst, polishing powder, metallurgical applications, batteries, glass, etc. So there are 5 different types of resources. Out of that, our resource is coming as mineral sand, and the thickness of the line will show that what the volume of the rare earths which can be extracted from the ore. So mineral sand, you can see the thickness of line is low, so therefore the volume available is quite low, but yet we are able to we are capable of extracting it. These are the chemical properties of rare earths, and if we look at the characterization, so they are the material with luster. They will tarnish readily in the air because they immediately react with oxygen. They have very high melting and boiling point, and because of this, they are finding application in metal alloys. They are strongly paramagnetic. Therefore, whenever there is a requirement of powerful magnet, strong magnet, the rare earths find applications there. They have excellent catalytic, optical, chemical, electrical, metallurgical properties. So therefore, they find application in nuclear reactors, in catalyst for petroleum refinery, catalyst for emission control, etc. Their occurrence is in low concentration, so there is a complex process of extraction, and individual production means normally they are found in a group together in the form of 17 elements together, or sometimes 10 out of 17. So separation is considered complex, and therefore very few countries have that technology, and this production requires number of steps, because if it is available in a concentration of 0.05%, so when we have to extract it, there is 99.5% is the waste material. So one has to find the solution for that waste material before the extraction. So these are some of the challenges associated with that. If you go to the internet, you will find that there will be lot many things mentioned about that it is very essential and so on and so forth. But if you look at the global consumption is only of the order of around 1 lakh 80,000 ton, but yet it is very important, and many of the advanced research work, advanced applications, it is used, and the country, those who are using, they feel it at very high supply risk, these materials. These are the reserves. So we are standing at number 5. China is having the highest reserve, and our reserves are at 5th number. And at the same time, it is logged with radioactive material. So therefore, the risk of extraction is also quite high. When we look at the demand and supply of refined rare earths, and if you go through this bar chart, the supply is higher, the demand is lower. But there is again a complexity involved. What is higher in number is the cerium and lanthanum, which are available easily, amply available in the earth crust, but the magnetic material, the availability is lower than the demand. So this also sometimes create the ambiguity about these material. Then the complex process or the complexity involved is because of being associated with the radioactive material. The methods of disposals are specialized because radioactive material cannot be left as it is. Then the leach residue generated is also to be disposed of. So there need to be an environment balance uh, out of the production of rare earths, and as well how much clean energy we are going to produce by that. So this needs a perfect balance, and that determines what should be the quantity which should be produced. Then the cost, associated cost is also quite high. The metallurgy of rare earth element is compounded by the fact that no two RE are truly alike. So what is happening that there are different ores, the extraction processes are different. Then because all these rare earths have a similar properties, so separation process is difficult. And at the same time, when we have to make compound or alloy of these materials with other material, that also requires a very a specific technology, a complex technology. So this is the area which is generated for research purpose for any of R&D institutions. These are the steps which are required to produce that, and I'll proceed that. So now here is a comparison. The Chinese ore is 6%. So therefore, in 3 steps, they can extract. Our Indian ore is 0.056%. We require more than double stages to extract this rare earths. This is about the Indian ore, which I have already explained. Now coming to the applications. So application side, now we have to remember one thing: the global consumption is only 1,80,000 ton till last year. But you see how many applications are here. Almost every sphere, this they are applied. They are applied in defense, nuclear energy, metallurgy, for improving their metallurgical properties, phosphorus in LED lamps, TV screens, mobile screens, medical equipment for MRI, CT scan, etc., catalyst for petroleum refinery, as well emission control, space, glass polishing, magnets. So there are variety of applications, but global consumption is low. This indicates that in every application, the usage of rare earth is in very, very minuscule quantity, but with that quantity itself, it improves the performance multifold. And that is where this is finding its increasing applications. These are few of the applications: electric vehicles, lamps, batteries, catalytic converter, solar panel, wind energy. Here are a few more. And these are the defense applications. You can see almost all kind of modern defense ammunitions, including launcher, frigate, submarine, nuclear reactors, then consumer side washing machine to tape recorder, speakers, tablet, mobile, everywhere rare earths are finding applications. Automotive, there are multiple applications, and these are the some more defense applications where the ND material, which is a neodymium oxide, which is alloyed with the iron and boron, and then it is magnetized to produce a high power magnet. And in the form of high power magnet, it is used in various defense related ammunitions. Few of them are listed here. And these are the applications for clean energy related with wind and solar panel, as well as the electric vehicles and EV batteries. Now, in the car itself, you can see how many applications of rare earth is there. There is a glass and mirror in the terms of polishing powder, LCD screen, that is europium, yttrium, etc., sensors. This has yttrium, then hybrid electric motor and generator, which makes it EV or internal combustion engine free automotive, headlight glass, then catalytic converter for emission control, battery, fuel additive, and apart from that, all motors by which this screens up and down, then your power steering, roughly around 25 motors are there in which are based on rare earths. So uh, whether it is, if it is an electric vehicle, then this electric motor and generator will be added for the engine purpose, but without EV also, all these applications are very much there in the automotive industry. The product value chain in case of rare earth is very high. Uh, what you can see that the green and gray color, we are already there. Now, when we come to this metal and alloy form, the Chinese government has created such a situation that the research and development in these areas in rest of the world is discouraged. So therefore, not much research has happened, and without having these technologies, one cannot use these materials. And if one cannot use, then all these applications which are very much there in the country have to depend on imports. So therefore, this metal alloy, uh, chemical compound, these are the area which needs the R&D organization efforts, initiative, so that the technologies can be developed and indigenous industry can come up. This is the structure of the industry: upstream, midstream, downstream, user industry. So as far as Indian situation is concerned, upstream is available, which we are taking care. User industry is available. We are a largest consumer market as of now, but midstream industry is missing because of the technology requirement. This is again the same thing explained in little elaborate manner. If we look at the magnet manufacturing aspect, so these are the areas where a R&D initiatives are needed. So NdPr metal, NdPr alloy, and if a technology can be developed, I think this could be a good reason for in the direction of self-reliance India. Now, if we look at what is the global RE ecosystem, so you can see that in case of metals, only three countries: China, Japan, European Union. Nor, of course, their capacities are quite low. And now we are trying to enter. Actually, in fact, we are establishing a small plant in Bhopal itself, where we are establishing the pilot plants for this metal extraction. But there is a scope for development. There is a scope for developing newer technology. Similarly, in magnet side, again, you will find that all these developed countries are there, whereas yesterday only a plant is initiated, but that is for samarium cobalt magnet. The mostly used NdFe magnet is yet to happen in our country. So this ecosystem, you can see the downstream side, only developed countries are there, and even upstream side also there are limited participants. These are some of the products and their availability in a specific country. Now coming back to IREL, these are our activities. Then we mine. Then our plants are located in Odisha, Tamil Nadu, and Kerala. At present, our capacity of mining is 10 million ton. With we are going to expand it up to 50 million ton by 2032. In mineral segment, we propose to increase from 600,000 ton to around 3.2 million ton. In rare earth extraction, from 11,000 ton to we are proposing to increase it by 3 times. And similarly, the refining segment, we are proposing to increase up to 13,000 ton. But we have to develop the market, and therefore we look forward to R&D institutions for developing the technologies. This is the project which was inaugurated yesterday. This is a samarium cobalt magnet plant where technology was developed by BRC and DMRL, and we have set up the project integrating both the one, and this is dedicated to nation yesterday by Honorable Prime Minister. And this is the project which is coming up at Bhopal, where these 8 technologies we would be establishing. And the focus of the project is, we can say, 3P, which is dwelling upon process, performance, and people. Process, with this has been developed new one, engineered at engineered in homegrown, based on homegrown technology. Performance is related with quality, and people is related with developing a skilled manpower. So tomorrow, if industry coming up, they can utilize these skilled manpower, and just like plug and play system, they can set up the industry. Apart from that, we have also developed some of the material from our uh, in-house technology development process. So that is a 3-way catalyst which can be used in the vehicles. And this for trial we have given to Varroc Engineering. Then zirconia coated parts. This is called thermal barrier coating, bias jet basis. This is tested on a Sukhoi 30 nozzle, and it has performed satisfactorily for more than 1,000 hours of flying. Then there are certain other coatings based on lanthanum zirconate, which found application in nuclear reactors, and this could sustain in high density graphite for more than 5 thermal cycles. So advantage is that their thermal withstanding capacities are quite high. Also, we have developed gadolinium oxide, which is used in nuclear power reactors to control the neutron emissions. Because with this control, we can generate the nuclear power. Otherwise, once it becomes uncontrolled, then it will go to the other direction. Similarly, we have also developed the extraction of dysprosium process, which is used in BRC for some strategic purpose. Now, this is the main part where I would like to call upon you. We have a technology development council where which is primary objectives are to promote eminent research laboratories, institutions, etc., to involve in research work related with rare earths. And in that connection, we award projects to the laboratories. Uh, here is the some of the thrust areas which I will advise my colleagues to share with you later. And the process of project proposal is like this, that we invite the project proposals from R&D institutions. There is a evaluation process by a committee, and after the approval, the fund disbursement and grant is given, and which will be subjected to periodical review. And then after the report submission, that project can be declared as completed. Uh, Here, though it is written that TRL 3 and above, but rare earths are the subject which are related with fundamental research, so we are open to that also. With this Technology Development Council, number of research projects have been completed, again by institutions in collaboration with industry. Some of them are this high field composite variesters, then nano size rare earth phosphate, uh, then efficient Syria zirconia based catalyst, then NIR reflective cerium oxide nanoparticles for energy saving glaze coatings, which are used in hospitals, etc. Then this zirconia and titanium dioxide, lanthanum zirconate as thermal barrier coatings, extraction of neodymium metal, uh, gadolinium oxide, titanium pigment nanoparticles, Then eco-friendly natural dyeing of cotton and silk using rare earth metal salts, process development for nano titanium from ilmenite, self-cleaning coatings on glass. These are few of the projects which are developed through our Technology Development Council. The new application area or new area where the research proposals can be submitted, though some of them are listed here, like development of lanthanum nickel alloy and its derived alloy for storage of hydrogen gas. You know that this is a sought after topic. Then dry reforming of a mixture of methane and carbon dioxide using RE based catalyst. Then energy storage component using RE. Fourth is RE titanates, RE zirconates as components of microwave applications, development of sensors. So with electronics everywhere, sensors are prominently used. Then rare earth compositions using lanthanum, cerium, praseodymium oxides in making ultra fine grained zinc oxide based non-linear dielectrics, conventionally called variesters. So like that, we have listed few, but yeah, this is the area which is means open, and I think that more than us, you will be in better position to conceptualize the project, and we are there to support you. Thank you very much, and I would also like to thank CSIR-AMPRI Laboratory, especially Director Dr. Srivastav, for giving me this opportunity and visiting the laboratory. Thank you very much.
Thank you so much, sir. Thank you for your knowledgeable, motivational, and very versatile lecture. Sir, in your lecture, you have talked about, you started about the basics of the rare earth. You talked about the importance of the rare earth, wherein we need the rare earth in the small amount, but it is having its importance in the clean energy, be it a neodymium, europium, terbium, dipsoprium, yttrium, paraxylinium, cerium, etc. You talked about the rare earth metals. You talked about their end use, wherein we are using it in each and every areas due to their versatile properties. You have also shared with us that we are fifth in number with respect to the reserves of this rare earth. One of the beautiful examples that you have shared with us is the car wherein we are using these rare earth in each and every part, which proves that seeing is believing. So really we believe that more in the car and other places, the rare importance of rare earth. You discussed about the global rare earth ecosystem, wherein we are very much fortunate that we are in Bhopal, and you have selected Bhopal as one of the place for establishing the work of IREL rare earth. Then one of the important achievement that you have shared with us, and we really congratulate you and your team, that samarium cobalt permanent magnet plant that has been dedicated to the nation by our respected Prime Minister of India yesterday. We are really congratulate you and thankful to you, your entire IREL community. And then you have talked about the Technology Development Council, and in your entire lecture, sir, you have shared with us that how and in which areas scientific and technological interventions can be made by the scientists, by the researchers, and we can have a new indigenous technology related to various areas. And I'm sure that you have also shared that you are not only focused to these areas where R&D is required, but apart from there, the scope is very much. And you have shared about the new application areas and many, many other things. We are really thankful to you for your knowledgeable lecture. Thank you so much, sir. So, ladies and gentlemen, now to move ahead in our program, as a token of respect and memory, the sir has been here. I would like to request our respected director, sir, to kindly present a memento to our chief guest of today's program. For the same, I would request the volunteers to please come in front. Sir, this is a special memento that we have chosen to present you in this very special occasion. Thank you, sir. As we know, we have been celebrating this National Technology Day as well as the formal inaugural and the formal curtain raiser of 1 week, 1 lab program. So this is the first memento, and This is the very special and the unique memento that has been suggested by your respected director, sir, to present to you in this occasion. Thank you so much, sir. Now, ladies and gentlemen, to move ahead as we are in a process of closing this, I would like to invite my colleague, Dr. Archana Singh, to propose the vote of thanks in this occasion.
Thank you, Dr. Sarika. Respected dignitaries present on the dais, guests from IRL, my colleagues and students present of the dais, a very good afternoon to all of you. First of all, I would like to thank Director Sir and the organizing committee to give me opportunity to deliver vote of thanks on this occasion. Thank you so much, sir. To start with, on behalf of CSIR-AMPRI, I would first of all like to thank you, our chief guest for today's program, Shri Dipendra Singh, Chairman and Managing Director, Indian Rare Earths Limited. Thank you so much, sir, for sparing time for us and from your busy schedule. You not only gave your valuable time for this program, but also visited our R&D output. Many thanks for your talk, where you showed the importance of rare earth element which can contribute significantly to shape our future. And also, many thanks to show the path how CSIR-AMPRI can associate with IREL. Also, your kind words for appreciation of CSIR-AMPRI motivates us to further excel in our work. Thank you so much. I also thank the dignitaries from IREL, Dr. Chandrasekhar, Dr. Talwar, and Mr. Mahavir for making their presence here. Thank you so much. Moving ahead, my sincere thanks on behalf of CSIR-AMPRI to our director, sir, Professor Avnish Kumar Srivastav, for your unstinted support for this event. Currently, sir is leading 2 labs, CSIR Animal and CSIR-AMPRI. Under your guidance and leadership, sir, we have done and are doing exceptionally well in R&D and other areas. Thank you so much for your constant guidance and encouragement. I would also like to thank Dr. Engineer Manish Mudgal, Chief Scientist, CSIR-AMPRI, coordinator of today's event, and his whole team for making today's program a success. Under leadership of our director, sir, and your team effort has made this program a success. My special thanks to all scientists and administration staff who has contributed in the release of today's capsule film. My thanks on behalf of AMPRI to Dr. Mohammad Akram Khan, Chief Scientist, CSIR-AMPRI, and coordinator of 1 Week, 1 Lab program 2023 for briefing us about this program. Under Director Sir's guidance and you as a coordinator, whole team is working hard to make this event a resounding success. Thank you, sir, and thanks to all of the members involved. Last but not least, thank you all of you for being here and listening this event. Thank you so much. Thank you.
Thank you, Dr. Archana, for the vote of thanks. Now I would request my IT team for the national anthem and for the
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Thank you so much to all of you.